Okay, next up is going to be volcanoes. For our volcanoes, our definition is going to be any opening in the Earth's crust through which magma has reached the Earth's surface. Okay, and these volcanoes, at least the three main types of volcanoes, are usually going to be found at what, once again, convergent boundaries, where those mountain ranges usually will form because the oceanic plate subducts underneath the continental plate. The first type of volcano is going to be a shield volcano. It has very mild eruptions, and as you can see, it's one of the largest forms of volcanoes. As we talk about just the size of the steep, it's not very steep on the sides, but the side, if you were measured from one side to the other, is going to be what gives it such the largeness in volcano terms. Okay. Once again, a volcano is going to be anything that has magma down below and it reaches to the Earth's surface, and usually through one or two openings, maybe more, depending upon the type of volcano. Hawaii has one of the largest volcanoes. That is a shield volcano. It has a huge magma reservoir below it. But then what you'll see is that that magma will reach the Earth's surface in several different ways, flow out of the volcano, and then cool on the sides, and forming more of that island. So here's a couple of examples of that. The Erta Ale, as you can see in the bottom right-hand corner, that is one of the most famous shield volcanoes. The Mauna Kea and the Fernandian uh, Island. The second type is going to be a composite volcano. Those composite volcanoes usually have steeper sides compared to that of a shield volcano, but they're also going to contain trapped gas, which leads to large explosions when they erupt. Uh, they're made of alternating layers of ash, cinder, and lava. And once again, so you can see on this picture, the magma reservoir will be down below, but then the steeps of the mountain have built up over time as magma rises, cools, and builds up. And so it traps a lot of that gas. And so when these usually explode, what you'll see is the top of the mountain will usually pop off or explode off because of all that trapped gas. Mount Fuji is going to be located in Japan, and it's one of the biggest composite volcanoes. We do have some composite volcanoes on our Pacific coast. Mount St. Helens. Some of your parents may know about Mount St. Helens in Washington, and then Mount Hood as well. Mount Vesuvius is actually another large composite volcano, and that's one of the biggest eruptions that has happened in the history of the Earth. Cinder cones are going to be the most abundant form of volcanoes. So they are the smallest of the three main types, but they also are going to be found more abundantly throughout the different convergent boundaries. What you usually see with this is, once again, there's going to be layers of cinder that build up over time. However, they don't have that trapped gas like our composite volcanoes. And so it's not as usually as explosive when they erupt as well. Picture of the cinder cone volcano. Okay, and with these, you can see on the top, they usually looks like their tops have blown off, but that's actually just a wide opening that has melted away over time as those cinders, or as the magma reaches the top of the cinder cone volcano. Here's a cool YouTube video. You can go check that out if you want to, detailing the three main types of volcanoes, and then they add in a fourth one as well that you can look at, and it shows you some of the history of the volcanoes throughout time as well. So we talked about most of our volcanoes occurring at convergent plate boundaries. The hot spot for volcanoes on Earth is known as the Pacific Ring of Fire. This is actually where 75% of the active volcanoes are going to be located. And you can see down below in the picture, that's highlighted with that orange lining. The Pacific Plate, which is going to be this plate right here, okay, as it moves, it's pushing up against all these continental plates like the where the United States would be located, and over here in China and Japan. And all those red dots are going to be different types of volcanoes that have risen up from there. So we have St. Helens there in Washington, Rainier's there in Washington as well. And then there's a couple more as you go down to South America as well that are part of the Andes Mountains. There's other types of volcanoes that can form as well. One of those types is going to be underwater volcanoes, which can occur at divergent boundaries. So this is where the two plates will pull away from each other. And the most famous result of that is probably going to be Iceland. So what happens is as the magma rises from the reservoir down below the Earth's crust, it's going to rise up, cool when it hits the ocean floor, and start to solidify. And as that solidifies over time, it starts to build up and form islands. And Iceland is supposedly a volcanic island that formed from the mid-oceanic ridge and is continuing to grow over time as that magma once again continues to cool as it hits the ocean waters and solidify, forming more and more of Iceland. Other types of volcanoes, you can see a similar instance of this take place, but it's usually going to be in the middle of a plate, and that's known as hot spots. So volcanoes that occur in the middle of a plate, not at a boundary, are going to be called hot spots. What happens there is the mantle plume of hot rock will rise from the deep inside the mantle, and as it continues to rise, it's going to erupt from the volcano at the hot spot and at the surface. And so what takes place then is the plume will remain in the same spot. So the magma reservoir will remain in the same spot, but as the plate moves above that reservoir, what you usually will see is a trail of islands that start to form, or a trail of these cooled magma start to form from that. And the great example of this is the Hawaiian Islands. If you've ever been to Hawaii, the islands there have formed over time. And this is a terrible picture, but what you can see from this is the Hawaiian hotspot is remained in the same spot, but as that lithosphere moves over time over top of that, you can see the little islands start to pop up and form as that magma cools and hits the ocean floor. And that's why the main island of Hawaii is continuing to grow, because of that hotspot that's located right below it. Here's a little bit better example showing that. So the movement of the plate is demonstrated by that white arrow. The hot spot stays in the same spot. However, the plate moves this way and it's continuing to grow. And so what you should see is on this side of Hawaii, the island continuing to expand. Great example of a video that shows you that in more detail. If you want to look it up, just type in this URL and that will give you some more information about Hawaii as well, and how islands are formed from volcanoes. Okay, that's our video for today.